Okay, so number 36. Let's get a nice little picture here. Is this the picture above? It is. Okay. So we've got a cliff. Something is shot upward off the cliff. We know that the angle here is 37 degrees, and it's being shot at 105 meters a second. The cliff is 125 meters tall. Determine the time it takes to hit ground level. So what is the time this thing is in the air? So immediately I'm thinking, like all projectile problems, that I can split it into two parts. Right? That the sideways stuff is moving at a constant speed until it hits the ground, and the vertical stuff is, well, that's bad. Speeding up or slowing down as it goes up, hits the top, and then starts speeding up as it comes down. And so there's acceleration in the vertical direction. So immediately my mind thinks, okay, the vertical stuff is going to determine the time. So if I can just find how long it would take to shoot this thing up vertically to the same height that it goes up here, then it'll take the same amount of time. So my first step then is to take this 105 and split it into x and y components. So v initial on the y and v initial on the x. I know that the whole thing is 105. So in the y, it's going to be 105 meters a second times the sine of 37 degrees, because this is 37. And in the x, it's 105 divided by cosine 37. Does anyone already have those numbers? Shh. 83. For which? Okay, so 84 with rounding. So I'm thinking, all right, if I shot this thing up with a vertical velocity of 63, the acceleration in the y is negative 10. Of course, this is assuming that everything up is positive, everything down is negative. The change in position is 125, and it's going to be negative because it's ending lower in the negative direction than when it started. And then I can solve for time. So based on that, I'm going to use number 3 and tweak it. I don't know why I'm still using a marker here. Okay, so that's not 0, unfortunately, right? So, actually, no. We know the number is negative 125. And this is 63t plus 1/2 negative 10 t squared. So I dropped the units because I recognize that this is going to require a quadratic formula. And it seems easier if there's no units messing with it. So negative 5t squared plus 63t. Rearrange one more time. Plus 125. So this is my A coefficient, this is B, and that's C. So I should be able to plug that into a quadratic solver and come up with two answers. Does somebody already have those? 14.64. What's the other one? Anybody have it? It's probably negative, right? So it's a negative whatever, but since it's negative, we know that that's not part of our physical solution. That would be going back in time. So we know now the time is around 15 seconds. So that's part A. Okay, so part B, determine the range that it goes. Well, once you have the time, the range is a lot easier. Because now we're thinking to ourselves, come back to this picture, it's moving at a constant speed sideways the whole time, and I know that constant speed is 84 meters a second because I figured that out down here. So 84 meters a second times the time that it's in the air, 14.6, and you get what? You're going to make me do the calculations? What is this? I don't get any perks with this job. 122.6. 1,226, how about, meters. Does that sound right? Okay, so that's part 2. Part 3, or C, they're saying the horizontal and vertical components of its velocity at point P, so just before it hits. So when it's right here, how fast is it going in the horizontal? Well, we can answer that right now. 84 meters a second. It's the same the whole time sideways. And then I need to figure out what's the new velocity right before it hits vertical. Well, that I can get because it's the same as the vertical would be right here. So I can use several different equations to find that. I could use number 4. It's probably the safest bet. So using number 4 here, Vy squared equals V initial y squared plus 2a delta y. So remember, I'm tweaking everything to be y instead of x because it's in the vertical. Trying to solve for this, I end up with, let's see, this was 63 squared plus 2 times negative 10 times negative 125. I dropped the units because I was running out of space, not because it's a quadratic. That's Vy squared. So when I plug that in, I'm getting 6469, and that would be, the units are meters squared, second squared. So then when I take the square root of both sides, I get Vy by itself, and this is a lot smaller number, which is right around 80 meters per second. Which means this guy, I drew it bad. It's not as big as the other one. So really it should be drawn more like this. 84 for this one, 80 for that one. So now I can, oh, it doesn't say to find the total. That's the next part. So just answering this is that part right there, finding what the components are. D is what's the magnitude of the velocity. So now that's saying let's put these guys together with Pythagorean theorem. (84 squared plus 80 squared). Whose phone is that? Okay. I'm getting, that can't be right. 116? Is that right? I guess it can be. I thought it was 160 originally. That would be crazy. Okay, so we got 116 meters a second. That's the magnitude. And now if I find the angle, that's the direction. So angle is going to be tangent of the angle I don't know is the opposite side over the adjacent. So the angle is tangent inverse of whatever that number is. What do you got? 43 degrees. Okay, so the total answer is 116 meters a second at 43 degrees, hush, below horizontal. Below because it's, here's horizontal and we've dropped below. Yes, I know the message will be in the video and me telling it to be quiet. That's right. And there's that problem. Any questions on that? Wow, that took me 9.5 minutes. Brutal.